Can't do anything until you know what all the numbers look like. You just got to figure all that out. So we got to kind of figure out what logarithms look like and how we use them. So, I have to turn that off instead of on. Isaac, are you done with that quiz yet? Go ahead and close out of the quiz. If you get done with it, you can do it. Here is your access code for the test. So I want you to finish this one. If you get done early, go back to that and do it. And your phone back here. It's already up there. Okay. Oh, it's not. It's already done. That's home again. That's to me. So you can go sit up there. And you can have Desmos open there. All right, so you can use your calculator on this. I want you to try to find the answers to these. Now, let me show you what you cannot do first. I'm going to warn you about what you cannot do. This is 2 to the x power. It is not 2 times x. What a lot of students want to do is they want to divide by 2. And they don't write this down because it's wrong. X equals, what's that going to be? 128, I think. Now, does 2 to the 128th power, does that equal 256? 2 to the 128th power might break the calculator. Oh, yeah. 3.4028E38. That, let me do it up here so you guys can see it. 2 to the 128 is this, see that E right there that the calculator is giving you? That is scientific notation. That's the way the calculator uses scientific notation. So it means you need to take this decimal place right here and move it 38 places to the right. So that's like a huge number, right? It does not equal 256. So dividing by 2 is not the way that you solve this. So what you're probably going to have to do is just guess and check. So try those two, guess and check until you can find the answer, if you can. Oh, wait, let me do that. So you're trying to figure out what x is. So like, for example, maybe it's 4. 2 to the 4th power equals 16. It is not equal to 56. So 4 is not the answer. Yeah, so you will definitely need this calculator. There. Did you get it? Hold on to it for just a second. Give everybody a minute to try, and then I'm going to... Let's see. Did I do attendance? Okay, that first one, Paloma's saying x equals 8. Is that what you got, Rhett? Yeah. Okay, if I check it, 2 to the 8th power, I got 256. Okay, that was good. X equals 8. How about number 2? Anybody got that one to work out yet? Is that one going to have a whole number that works? It is not, because if we do like 3 squared, we get 9. If we do 3 to the 3rd, we get 27. So it's somewhere between 2 and 3, which means we got to like use decimals there, right? Has anybody got close on that one yet? Try some different numbers, see if you can get close. Anybody? 2.7. So 3 to the 2.7 would be 19.41. That's pretty close. Anybody get closer than that? So it needs to be a little less than 2.7. Let's see if we can get something closer. But 2.6 is going to be too low. 2.68. Alright, hold on, I gotta hit 3 to the 2.68. You guys know that raises to the power. Everybody's got that. I know we haven't used these calculators a lot. Well, that's pretty close. That's closer, right? We need a little more than that. What if we try like 3 to the 2? That's close, but I think David's 2.68 is a little closer. But what if we put like a 8.1? That's a little closer, right? We could keep doing this for a long time. In fact, in second period today, I did this exact same thing. And what I'm going to do right now, have you guys seen this before? The squiggly equals. What does it mean when I use squiggly equals? Approximately. I'm close, but not exact. So I'm going to go ahead and say this is about 2.68 right there. Close enough for what we're doing right now. Now, if we did that long enough, we could get even closer to prove that in second period today. About 30 minutes after we finished this question, Elijah Tilley raised his hand and had gotten it to actually equal 19. He had like 10 decimals out there. I hope he paid attention to something on the rest of the notes, because he had sat there and messed in his calculator until he got, I should have wrote down what it was, until he got it to work where it was 19. Now, the interesting thing is, it still wasn't exact. It had just reached the limits of the calculator, where the calculator was rounding it to 19, because the calculator can only hold so many decimal places before it's just going to round it off. But it was probably accurate enough for anything you would use it for. Now, example 1, we could figure out by guessing and checking, and it wasn't that bad to figure out by guessing and checking. We just tried a few numbers till we got something. Example 2 is an example that is one of the reasons why we need logarithms. Okay? Because if I have 3 to the x power equals 19, I'm trying to solve for that x, which means I'm trying to get rid of the 3. Right? But it's not the same as 3 times x, right? If I had 3 times x, I'd just divide it off. This is what we call, let's label it right here, this is what we call a base of an exponent. So this part is the base, this part is the exponent. So what we're going to see is that when we have an exponential, we are going to use logarithms to get rid of those bases, to rewrite for these. Just before we go to the next slide, let me make sure we're clear. I'm going to write down a few equations. Let's do, or not equations, but just expressions. Which ones of those are exponential or exponential expressions? What do you think, Carolyn? That's actually the opposite of correct. The first and the last do have something in common, but they are not the exponentials. Okay? These are x being raised to a power, and that would not cause something to be exponential. These two actually are exponential. Alright, for something to be exponential, the variable is in the exponent. So just to give you an example, you don't have to write this down, just to show you. Like if I have x squared equals 16, then I'm trying to get that x by itself. How do I get rid of a square? What undoes a square? A square root. I would just square root both sides, right? That'd be x equals, it's actually positive 4 and negative 4. We'll talk about that in more detail on some other stuff that we do. But to get rid of a square, I use roots, right? If I have x to the 5th equals 10, how do I get rid of something to the 5th power? We did just a little bit of this when we did inverses. We did a 3rd power. We still used a root, but what did we put out here? 5. The 5. So we do a 5th root, right? So to get rid of exponents that are numbers, we use roots, which is not what we're doing right now, so you're not going to do that anymore. If you didn't follow that, it's okay. What we're going to be dealing with is when our exponent is the variable. Okay, that's what we're going to see for these. Those are exponential equations. Whenever our exponent is the variable. You guys see the difference between those? So in these, your exponent is a number. In these, your exponent is a variable. The exponent being a variable is what we're talking about here. Okay. So let's move on. All right. This is going to be the key idea of all of it. Of everything we do in this chapter, really, is that a logarithm is the inverse of an exponential function. Okay? So a logarithm is the inverse of an exponential function. Right? We already know some about inverses, right? We talked about them earlier. What is the inverse operation of adding? Subtracting. What is the inverse operation of multiplying? Dividing. What is the inverse of squaring something? Square root, right? So we know some of those inverses already. The inverse of an exponential is a logarithm. So whenever I was saying we got this 3 and we need to get rid of it, that's where the log is going to come in. Okay? A logarithm answers the question, what power can you raise a number to in order to get a certain result? So when we get to the equation part, our power is going to be our variable. That's where we're going to be trying to solve. What we're going to see is that if we have an exponential right here, like this, with a base of b, and it equals a, if I want to rewrite that, what I'm going to do is I'm going to look for whatever the base is. The base over here for the exponential is the b. To get rid of a base that is b, we would use a log with a base of b. We also call that a base right there. And that would cancel that out. But if you do something to one side, you also have to do it to the other. So then we would have x would equal log base b of a, which, if you write it over this way, would be like that equation looks. So there are two things that we have to know how to do today. Well, I guess we'd call it three things. We need to know how to take an exponential expression and turn it into a logarithmic expression. That's the first. We need to turn logs into exponentials. And we need to be able to use our change of base formula, which I'll show you here in a second. So let's look at what we'll do here. All right, seem confusing? Yeah, second period was like really staring at me funny. at this point. If it seems confusing at this point, that's probably pretty normal, okay? I hope that as we do these examples and do some problems, it is going to get way easier. Like, oh yeah, this is actually not that hard, okay? All right, so we're going to start with these types of problems. We have to rewrite each logarithmic equation in exponential form. All right, so what you want to do in these, so these are all logs. We can tell that because we see the word log, right? What we want to do is we want to locate, if we're trying to get rid of a log, we need to find the base, all right? So the base of a log is this little number right here. And logs and exponentials are inverses of each other. So since I have a log base 3, if I do 3 raised to the power over here, so if I do 3 raised to log base 3 of 81, right? So that little arrow right there means that I'm raising that up to the power. And then I also do 3 raised to the power of 4 over here. Careful on how you say it. You are not raising the sides to the third power. That would be like if you did, that would be like if you, cubed something right there. That's not what we're doing. We're making these powers of 3. We're doing 3 to the power on each side. So what happens here, if you do 3 to a log base 3, the log and the 3, log base 3 and the 3 are going to cancel out. And you're just going to be left with what's right here, which is the 81. And then on this side, this is just 3 to the 4th. We just write it 3 to the 4th. Which side? It does not. So I just kind of left it where it's at. Now, when we get to the problems that we're going to do on IXL, most of the time IXL writes it the other way. They write it 3 to the 4th equals 81. You can switch the sides of the equal sign, and it doesn't matter as long as you just change the whole side. So you could see this written either way. I don't care which way you write it. Both of these are correct. But you do need to realize they're the same because a lot of times this is going to be either calculator active or it's going to be like where you're just filling in a blank, and it may be in the other form. So this is all I'm asking you to do right now, just to rewrite. You could leave it here. If you switch the other sides of the equal signs, that's fine. We're not solving anything. We're just rewriting right now. The reason we need to know how to rewrite is because we are going to use that to solve later. But right now, we're just rewriting, okay? So if I look at the example 4 here, I've got a log. I'm looking for my base. It is a 5. Logs and exponentials are inverses of each other. So to get rid of that log with a base of 5, I will do 5 raised to the power on the left side. That means I've also got to do 5 raised to the power on the right side. 5 to a log base 5 is going to cancel. X will equal 5 to the 3rd. Now, right now, you're just stopping here. I'm just asking you to rewrite. Now, you can kind of see on this one, that would solve that equation, right? We could do 5 to the 3rd. It's going to be 125. The answer to this equation will be 125. So that's sort of like where we're going tomorrow. But for right now, we're just rewriting. You're right. We're not doing it tomorrow. Monday, we're going to do that. Thank you for setting me straight there. Okay. So, who thinks they got the idea and could do number 5? All right, Caroline, what will we do? Good. Perfect. And I like the way you corrected yourself when you were saying it. She almost said x to the power 2, but really it's 2 to the power of x. So we cancel that out. What are we going to get, Caroline? Perfect. Okay, that's all we're doing right now. We're rewriting. Okay, so that's all we need to do. All right, 6 is a little bit different. Not really. You're doing the same thing, but it's a little weird because everything else has been numbers so far. Who thinks they can do 6 for me? All right, Paloma?
I just write x to the power 2 is equal to
Good. So 16 is equal to x to the power 2, or x to the power 2 is equal to 16. And if you have done these before, they may have taught it differently. I should probably have put that warning at the beginning of this.
We don't do like the left thing.
Yeah. Lots of times, whenever teachers teach this, they teach just like the formula of rewriting instead of teaching it as inverses. I've done it both ways. I like doing it this way because I think it makes it easier whenever you have the more complicated situations that you get into. So if you go watch YouTube videos on this, or if you're looking at like the answers on IXL, they may do it differently than I've done it. I don't care. You can do it either way as long as you're getting the right answer. It does not matter to me which way you have done it. I kind of like teaching it this way because it kind of helps students when they get to those problems that are a little bit more difficult. But you can do it either way. It's fine. Okay? All right. Okay, let's look at the other way. Okay, so these are exponentials, and we are rewriting them with logs. So just like with our exponentials, we need to look for the base. For an exponential, your base is the number that's being raised to that power. Okay, so like for example 7, the base is 5. So to get rid of a base of an exponent, you use a log, and that log must have the same base. So we would do log base 5 over here, and log base 5 over here. That will cancel this out. You'll have a 3. You will get log base 5 of 125 over here. Okay. Peyton, what's my base on number 8? 4. To get rid of a base, we're going to do a base of an exponent. We're going to do log base 4. On the side, it'll cancel out. Then we got to do log base 4 on the other side as well. So we got x equals, when you write this, this is a log. The 4 is a subscript. It's a little bitty number. And then the 8 goes here. You can put parentheses around that 8 or not. Either one is correct. So 8 is not like an exponent there. It's like a normal sized number. Okay. Let's see. Sawyer, what would my base be on number 9? 10. All right. So to get rid of a base 10, what should I do? We'll do the log with a base of 10, which will get rid of that over here. We'll just have a 3. And then we'll do log base 10 on the other side, which will be this log base 10 of 1,000. Now, there is something about log base 10s that I'm going to teach you here in just a minute. So, when we learn a little more, we're going to write this a different way. But just keep in mind that's coming. We're going to leave it like that for right now. Okay? David, what's my base on number 10? 8. How do I get rid of that base 8? Good. Log base 8. We'll get rid of this over here. Log base 8 of 12 over here. So we got x equals log base 8 of 12. Okay, so to get rid of bases on exponents, we use logs. To get rid of bases on logs, we use exponents. Okay, questions so far? All right, there are a couple. Oh no, we got to do this one first. Sorry. Okay. we do need to be able to type these into the calculator. If you have a fancy new calculator, your calculator might let you type in a log with a base. I think most of these, there's a couple of these that might be new that might be better, but most of these probably will not. Also, it's in our curriculum that we have to learn about the change of base formulas, so there may be some sorts of problems that they might give us. Change of base formula. Change of base formula is super simple. And it's very useful for typing things into the calculator. Now on Desmos, you can type it in with the base, so you don't have to use this on Desmos, but you could if you wanted to. I like to use it even on Desmos because it's just faster to type in, but you can do it the other way on Desmos. So if I have log base b of a, then that is going to equal log of a over log of b. Whatever number is the base right here. Hold on, something right. Whatever number is the base right here, that goes on the bottom. Now, we're going to talk about in a minute, like if you hit the log button on your calculator, it has no base. We're going to talk about that in just a minute. But for right now, all you need to know is that you've got, your calculator doesn't have a log base something button. It also has this LN button below here. You can actually use either one of these. So all this means for this is if I want to figure out what log base 4 of 35 is, I could type into my calculator log of 35 divided by log of 4. Okay, whatever the base is always goes on the bottom, which should make sense because bases are on the bottom of things, right? Log 35, oh, double logs. Log of 35, make sure you close that parentheses of divided by log of 4. We get 2.565 if we want to round that off. In general, unless I tell you otherwise, make sure you keep at least 3 decimal places. If you keep more, that's fine too. So who knows how to type in number 12? What would we do, Presley? What? The 8 is the base. It goes on the bottom. Log 4 over log 8. And so it has nothing to do with which number is the, like, is the biggest as far as, like, higher number, right? That base, even if it's bigger than the other, it goes on the bottom. We had that confusion in second period as well. Like, I told them that the big number goes on top. I meant, like, the one that's actually, like, physically bigger, not the increased value there. So, log of 4 divided by log of 8 is going to give us 0.6 repeating. Oops. What is it doing? Having a fit. Alright, let's see now. 0.6 repeating. So, Rhett, how would I type in 13? Log 60 over log 2. So, log 60 over log 2. And you'll actually find that if you use the LN, it works the same. So, LN of 60 divided by LN of 2 is going to give you the same number. So you could actually use either one of those. And we're going to talk about what those are here in a second. So 5.906. Okay. Questions so far? All right, there are a couple types of special logarithms that we have to talk about. Okay, so sometimes there are logarithms that we are going to see used a lot more often, and that is the reason, because of that, we give them special names. The common logarithm is the base 10 logarithm. This is what would be used for the Richter scale, because each level is 10 more than the one before it. So whenever we're doing a common logarithm, we just write log. Right? This button on your calculator that we were just using that just says log, that is a common logarithm. It's got a base of 10. Okay? So if you see log written without a base, assume that the base is 10. If it's anything besides 10 or e, they will put the base there. Okay? There is also a natural logarithm. And there is a number called e. Have you guys seen the e before? I'm thinking maybe not for most of you. And when we get to some of the exponentials, we'll talk a little bit more about where it comes from. But it is called, this looks like Euler's, but it is not English and not an English name. It's Euler's is how you pronounce it. Euler's constant. It's a lot like pi. It's actually stored in your calculator. If you look right above your division symbol, you've got that little blue E. So if you hit the blue button and the division symbol, it'll put an E right there. Try that on your calculator, see if you can find it. If you hit enter, it'll give you the approximation for it. It's 2.718281828, and that keeps on going forever. There, it actually is not repeating. It looks like it does repeat, but it does other crazy stuff after it. Okay? So we'll talk more about why in the world you would need to know that number or where it comes from later, but for right now, all you need to know is that if the base is e, it's ln, natural log. Now, evaluating these on the calculator, super duper easy because you don't have to do the change of base. Because if you got log of 52, you just have to type in log of 52. Right? It's understood the base is 10. We get 1.716. You guys try those other two for me, see what you get. The LN button is just right there below the log button. Okay. Addie, what'd you get for 15? 902 3. Is that what you guys got? I don't know about that. That might not be right. Let's see. Oh, I bet you hit the log button. Because that would be about right. Yeah. It's the one right below it. LN. It's the one right below it. Perfect. 2.079. Peyton, what did you get for 16? Negative 0.407. That sounds about right as well. It should be a negative for sure. So, those you're just hitting the buttons on the calculator to put those in. Oh. I think it is. I think Peyton wrote it down wrong. Let's check. Natural log of 5 divided by 8. Oh yeah, he just wrote it down wrong. He'll be okay. Alright. Questions so far? Alright. Now let's practice here. I obviously forgot to put a question there for number 21. So I'm going to make you one up. Let's do a log. Let's write it the other way. Let's write it 8t7 equals log of t. We're just going to put that in there since I forgot to fill that in. Alright, so if we are looking at these problems, they're all mixed up now, so we've got to decide. For every problem, we got to find the base. That's the first thing we got to do is find the base. So, Silas, what is the base for number 17? 10. It is 10. And it is a base of an exponent, right? So to get rid of a base of an exponent, we've got to use a log with the base of 10. So x will equal log base 10 of 60. Now, I just told you that if we have a base of 10, we don't have to write it. Kind of like if you have a square root, do you have to put the 2 out here showing it's a square root? You do not. It's assumed that that is the 2, right? So if you have a log base 10, you don't have to write that 10. So you can write this. It is technically correct, but never will you find that as an answer choice on something multiple choice. It's going to be simplified down. Something like IXL might tell you you're wrong if you put it in like this. So, because it's not simplified down. So we could just write that as log of 60. Because if we have a base 10, we don't have to write it. All right. 18. On all these problems, we're looking for the base. Where's the base?
It's 10.
It is 10. It was much more obvious on the other problems what the base was, but if it is not written and it's a log, you assume it is a 10. Okay? So, if I want to get rid of a log base 10, I need to do 10 to the power. 10 to the power on both sides. So, x would equal 10 to the 8th power. Okay? Questions? If you just have log, let's not do yellow, log of 9, it is assumed that it is a 10. So if it's not written, if it's not there, it's always a 10. Okay? Unless it's like number 19. 19 doesn't even say log, right? 19 says ln. And so ln was a special one, right? Ln is the same, I'm going to rewrite it this way, the same as a log with a base e of x equals 12, right? So we just have to know that if you see ln, it's the same as log base e. You don't necessarily have to write that step, but it might help you too so that it works like the other problem. So if my base right there is e, and I want to get rid of that e, I would do e to the power, e to the power, x equals e to the 12th power. Okay, questions so far? Lily, what is my base on number 20? It is e. Perfect. Okay, so to get rid of a base of e, that's an exponential. I need to use a log with the base of e. Now that log base e will get rid of that e. I'll get 5 equals log base e of x, but it is technically correct to write that, but if you are writing log base e, it looks like you don't know what you're doing. because log base E has the special name, it is natural log. Oops, not an X right there. Hold on. It is natural log, so we would say 5 equals natural log of X. So you may even want to make yourself a note somewhere that log, just a plain log of X, is the same as log base 10 of X. And if I've got natural log of something, it is the same as log base E of X. Okay. Laura, on number 21, what's my base on that one? It's not 87. The base is going to be your little number that's below, but I don't have one. So what should it be, Adriels? What? What did you say? T? No, it's not the T. It's 10. There is an invisible 10 hiding right there. So because if I see just a plain log, if there is just a log and there's no little number, then it's got an invisible 10 that is right there. Okay? So that invisible 10 right there that was hiding, that is what we've got to get rid of. To get rid of it, we got to do 10 to the power. 10 to the power, we'll get rid of this over here. 10 to the 87 would be T. 10 to the 87 has 87 zeros. That's a big number. So, this is what kind of crazy stuff you come up with when you make up the problem last minute there. Alright, let's see. Silas, what is the base for number 22? Very good. How are we going to get rid of that base for that exponential? It's already an exponential. So to get rid of an exponential, we use a... I could do log base E, but that kind of a little bit looks like you don't know what you're doing. So if I want to really do a good job here, instead of calling it log base E, I could do ln of 5, because log base E is the same as log ln. Okay. All right, so we have about 15 minutes, and if everybody works really hard on our IXL, I hate IXL, but they don't have this in Delta Math. I prefer Delta Math, but they don't have this topic in there. So if you go to your IXL, if you have not been into IXL, you guys should have gone into it whenever you were in EHS time. So, however, second period was still acting like they didn't know how to get in. So if you go to IXL, you are going to go to Algebra 2, S3. That's where we're going. So Algebra 2, S3. And I'm going to pull it up right here. Now, I would like for now you can write on your note sheet or something. You don't have to have a special sheet of paper for this. I'm not taking it up. But I would like to see, at least at first, or if you're struggling, I want to see your pencil out instead of just trying to think about it. When you get really good, maybe you can think about it. But whenever you're doing these problems, okay, like this one, let me write it bigger so you guys can see. Log base 6 of 6 equals 1. My base here is 6. I'm rewriting an exponential form, so I want to get rid of that 6. If it is a base on a log, I got to make it an exponent. We'll get rid of this over here. I will have 6 equals 6 to the first power. Now, iExcel, for the most part, is writing it this way. It's switching the sides of the equal sign, right? So to get this to match what I have here, I need to put a 6 right there in that blank. So 6 to the first power equals 6 for that. Okay, does that make sense what we're doing there? It leaves a blank for that. This next one right here, I've got log 1 equals 0. Ooh, where's the base on that? If I've got log 1 equals 0, it's hiding, right? It's right there. It's an invisible 10. So I would do 10 to the power, 10 to the power. 1 would equal 10 to the 0. Notice, again, it's backwards here. They've got their 1 on this side, so they've got 10 to the 0 equals 1. So I need to put a 10 in that spot right there. Okay, so work on those. I'm going to come around to help. If you guys are getting stuck on it, if everybody's working hard, then it will not be